Video, I will be talking about the ideal gas law. For the ideal gas law, it only pertains to gases of like molecules or atoms that do not interact with one another. In this figure, it shows gas atoms and molecules that are widely spread from one another due to weak or no interactions, as they are more dependent on the state rather than the path. It is dependent on the number of molecules or atoms per unit volume, the pressure, and the temperature on the atoms. Here is another figure of what it is like for gas atoms to move ideally in a given volume. You can see as they move around, they are colliding with one another and with the walls, creating a type of pressure. This is all shown by the ideal gas equation, PV equals nRT, where P is the pressure, V is the volume, N is the moles, R is the gas constant, and T is the temperature of the gas. By the ideal gas law, pressure and volume are indirectly proportional to one another, which is seen by this graph where it is volume versus the inverse of pressure that create a linear relationship. If it was just volume versus pressure, an exponential line would be seen instead. By the ideal gas law, pressure and volume are directly proportional to the moles and temperature. It is represented in this graph that shows an isothermal system. It is seen that as pressure and volume are held constant and temperature is increasing, both volume and pressure are increasing along with temperature. For the ideal gas law, it is one property to understanding the kinetic theory of gases. Thank you for watching.